Here are some more answers from the Unit 10 exercises. In exercise number 3, what we have is a change in estimate. When you purchase an asset, you make your best guess about how long you're going to use it for and what the value of it is going to be at the end of its life, but you're not tied to it. There's going to be times where you have an asset on your books that you thought you were going to use for a set period of time, and you realize either A, hey, we're not going to be able to use this as long as we thought we were going to, or B, we're going to be able to use this even longer than we thought we were going to. That's what's happening here with McGregor Eyewear. See, on January 1st of 2013, they purchased a piece of equipment, and this equipment cost them $370,000. At the time of purchase, their guess was it was going to have a useful life of 7 years and a salvage value of $20,000. They've been depreciating it using the straight line basis. And then on January 1st, 2018, which is 5 years to the day after they purchased it, they realized that the useful life of this asset should be 10 years instead of 7. So they're sitting there looking at this asset and they realize we're going to use this thing longer than we thought we were going to. Let's make a change to our estimate and then therefore make a change to our depreciation rate. Because this asset's going to be even older when they get rid of it, it just makes sense that it's going to have a lower residual value than they already estimated. So they're lowering their estimate for the residual down to $10,000. What they need to do now is they need to figure out what their new depreciable base is, what their new rate of depreciation is going to be, and prepare a depreciation table for the remaining useful life of this asset. Let's start with the first part. To figure out what our new depreciable base is, we need to figure out what the book value of our asset is at this point. Well, book value is just historical cost minus accumulated depreciation. So historical cost, McGregor on January 1st, 2013, paid $370,000 for this piece of equipment. How much depreciation has it accumulated? Well, we got to go through the numbers we have and figure that out piece by piece. So the first thing, we know that our historical cost at the time of purchase was $370,000, and we made an estimate that its residual would be $20,000, which means that our depreciable base at the time that we purchased this was $350,000. That was the amount of value we were going to take off this asset over its life on our books. And because we're using the straight line method, we're going to take away an equal portion each year. Well, since we assumed initially that it was going to have a useful life of 7 years, we took 1/7 of that depreciable base away each year, which would be $50,000. And we did this from the time we purchased it on January 1st, 2013 till the time we're going to change our estimate on January 1st, 2018. So that's 5 years that have passed. And if we'd been depreciating this asset at $50,000 per year for the last 5 years, it at this point should have accumulated $250,000 worth of depreciation, which means that its value on McGregor's books at the time they are changing their estimate should be $120,000. So when you make a change of estimate, your net book value becomes your new historical cost for the purpose of preparing your depreciation table. Which means from that net book value at the time we change our estimate, let's subtract our new salvage value of $10,000 and determine that the amount that we need to take away from this asset over its remaining life is $110,000. So now that we have our new depreciable base, let's make our depreciation table. Let's start with the year we're changing the estimate. We're changing the estimate in 2018. We have already figured out that our depreciable base is going to be $110,000. Well, what is our rate? It's straight line. We need to take away an equal portion each year for the remaining life of the asset. Well, what is the remaining life of the asset? We're saying that this asset is going to be useful for 10 years from the date we originally purchased it. We originally purchased it on January 1st, 2013. So if it's useful for 10 years, that means it's going to be useful until January 1st, 2023. We're making this change in estimate on January 1st, 2018. So to get from 2018 to 2023 means we're going to use it for 5 more years. And therefore, since we're using straight line, our depreciation rate should be 1 over remaining useful life, or 1/5. So we're going to take 1/5 of the depreciable base away each year. So if our depreciable base is $110,000 and we're taking 1/5 away each year, that means we're going to depreciate this piece of equipment at a new rate of $22,000 per year. And our accumulated depreciation would be $22,000 because it's the first year, bring our net book value down to $98,000. And then McGregor is going to go and record the same amount of depreciation each year because it's straight line, decreasing our book value by that $22,000 each year, increasing our accumulated depreciation by $22,000 each year. And they're going to do so for the remaining 5 years of this asset's life, until in 2022, the last year that we're going to use it before we dispose of this on January 1st, 2023, we depreciate the final $22,000, increasing our accumulated depreciation to $110,000 and decreasing our net book value to $10,000, which is its residual value, so we know our table is correct. In exercise 4, we have a similar concept. We have a revision and estimate, but this time it is for a natural resource, which means we're not going to depreciate it, we're going to deplete it, because depletion is just depreciation for natural resources. We have a company called the Plainview Oil Company, and they are using 1,500 acres of land in Little Boston, California to search for oil. They're going to use the full cost concept to determine the cost of extracting oil, and that means that they get to include the cost of all of their failures. No one digs for oil once and finds exactly what they're looking for. They're going to fail at a time. Well, that's a necessary cost of getting a well that actually produces oil. So under the full cost concept, they get to include a cost of all of their unsuccessful attempts. This well, once we find it, they're going to expect that it's going to produce 35,000 barrels of oil. They had the following costs to get the successful well going. They spent $5.7 million to acquire the land that they were going to drill on. They spent $1 million searching around on this land for wells. Some of them were successful and some were not. They spent $100,000 transporting equipment to the site, and they spent $200,000 to build an oil derrick, that big thing that you place over the top of an oil well that captures the oil as it comes out. In total, that's all of the things that they had to pay for. And since we're using the full cost concept, we get to include the full cost of everything that it took to get a producing functional well, which is the $5.7 million, the $1 million, the $100,000, and the $200,000. In total, we spent $7 million to get this well up and going. Well, from that, let's subtract our salvage value, and it's not listed here, but it doesn't need to be, because with natural resources, the salvage value is always zero. Who's going to buy a well with no oil left in it? It has no value to anybody, so its salvage value has to be zero. Yes, there is a way to convert a depleted well or a landfill or something like that into just land, but that's for a different accounting course. For us, we're just going to say that since it's a thing that we're going to garner natural resources from, at the end of its life, its salvage value has to be zero because there's no natural resources left. The estimated life in units at the time that we got this well producing was 35,000. So to figure out our depletion per unit, we take our total cost minus our salvage value, our depreciable base, and we divide it by our estimated life in units, because depletion is essentially just units of production, which means that our depletion rate should be $200 per unit, or for every barrel of oil we pull out of this well, we're going to deplete it by $200. Well, during this first year, they extracted 15,000 barrels of oil. So if we're going to deplete it by $200 per barrel of oil and we extracted 15,000 barrels, that means that our depletion expense should be $3 million during the first year. So now let's record our journal entry to recognize the depletion on this asset during its first year. On December 31st, we are going to have a depletion expense of $3 million. And we're going to put it, in this case, into an accumulated depletion account for our oil well. Companies can, if they want to, just take it out of the value of the asset, so they could credit oil well right here if they wanted to. But Plainview, as it says in the bottom line, is going to record the depletion in an accumulated depreciation account. So let's credit accumulated depletion of well for $3 million. And we recorded depletion on a Little Boston well during its first year. In year 2, Plainview is going to make a revision of their estimate. So at the time that they purchased this well, they thought there was 35,000 barrels of oil in there, and they extracted oil during the first year, and they realized there is way more oil in this well than we originally thought. they're thinking now, even after they've extracted a year's worth of barrels, there's still 40,000 more barrels of oil within this well, which means they need to revise their depletion rate. How are they going to do so? They're going to start by taking their historical cost. We've already determined it was $7 million. They're going to subtract out any depletion that they've already had. They used it for the first year, which means they recorded $3,000 or $3 million worth of depletion, which means its net book value is $4 million at the time. So now that we have our net book value and we know that it's going to have a residual or salvage value of 0, we can just divide that net book value by the remaining units of production to find our revised depletion rate. Well, there's 40,000 barrels of oil left in here, which means our depletion rate should be $100 for each barrel that we extract. During year 2, we extracted 15,000 barrels, which means that our depletion expense recorded during year 2 should be $1.5 million. And the entry is going to be exactly the same as we had last time, a debit to depletion expense, and since they choose to use an accumulated depletion account, a credit to accumulated depletion of well for that same amount. We recorded depletion on the Little Boston well for its second year of use.